In this next video, we'll continue multiple choice related rates AP questions with 1985 AB9. The volume of a cone of radius r and height h is given by v equals 1/3 pi r squared h. And so we have a cone here, and we know that the radius and height are both increasing at a constant rate of a half a centimeter per second. And that means that dr dt equals dh dt is equal to 1/2. Then at what rate in cubic centimeters per second is the volume increasing? So we want to know what dv dt is when the height is 9 centimeters and radius is 6. So this time we have three rates. We have dr dt, we have dh dt, and we have dv dt. And so we need a formula that's going to relate together r, h, and v, and of course that's given to us at the very beginning, and that is velocity is equal to 1/3 pi r squared h. We're going to differentiate both sides with respect to time. The critical part of solving this problem correct is to know that we have to use a product rule here on the right side, because both r and h are functions of time and they're multiplied together. So if we're going to use the product rule, I will let the first function be 1/3 pi r squared and the second function be h. So for the product rule, we want the first times the derivative of the second, and the derivative of h is dh dt, plus the second, which is h, times the derivative of the first, which will be 2/3 pi r dr dt. And aside from a little simplifying, the calculus is all done. And we can plug in. We have a value for h, for r, for dh dt, and for dr dt. So we start with pi over 3. Our r is 6 squared, will be 36. dh dt is 1/2. Then we have 2 pi over 3. R is 6, h is 9, multiplied together is 54. dr dt is 1/2. Simplifying, we get 6 pi plus 8 pi for a total of 24 pi, and that would be answer C. So we'll pause here for a second and then go on to the next. In the next problem, we'll go on to 1985 BC 22. The area of a circular region is increasing at a rate of 96 pi square meters per second. So we have our circular region, and we know that the area of that region is increasing. So that gives us dA dt, and it's increasing at a rate of 96 pi meters squared per second. So dA dt is 96 pi meters squared per second, when the area of the region is 64 pi square meters. So when A is equal to 64 pi meters squared, how fast in meters per second is the radius increasing? So we're looking for dr dt. So in this formula we have a dA dt and a dr dt, and we're looking for a formula to relate those two together. And so obviously we use A equals pi r squared. We want to differentiate both sides with respect to time, and so we get dA dt is equal to 2 pi r dr dt, and we need to solve this for dr dt. We know dA dt, 2 pi are constants. We need to find out r according to the constraint given above. So since area is pi r squared, and we want to find the radius when the area is 64 pi, pi's cancel, we get r squared is 64, and so r is 8. We can now plug in all the givens in our derivative equation. dA dt is 96 pi. That's equal to 2 pi times 8 times dr dt. So we're going to divide both sides by 16 pi, and that leaves dr dt equal to 6 meters per second, and that's our final answer, choice A. And that will do it for these two problems.